Casting is an ancient process with many different exciting applications. Today we'll show how we can combine casting with contemporary techniques to produce the cast of the human head. The entire casting process is thrilling, but let's not get ahead of ourselves. The first step of this process is to scan the head to obtain the 3D profile. For this, we were able to collaborate with Georgia Tech's Body Scan Lab in the College of Design. Our test subject here was one of our group members, Philip. He'll wear a special hat here to prevent his hair from disturbing the scan. After just a few minutes of scanning, our 3D CAD file is complete. Just a bit of patching the holes and rough spots in the model, and it's time for 3D printing. We'll use the Invention Studio in the MRDC for our 3D printing. This is the easy part. Just upload the 3D profile and wait for the print to complete. After obtaining the 3D printed pattern, it's time to create the mold. We shopped around a bit and found that silicone rubber would be a perfect fit for our uses. For the mold, we start by cutting up an old milk carton. Its square shape is a convenient container. Next, we pour the silicone components together and begin mixing. The silicone begins hardening immediately, so it's important not to lose your head and to begin pouring the mixture into the container immediately. The curing process takes 30 minutes, and then just a little bit of cutting and wiggling later, and the silicone mold is ready for use. With the mold complete, we're ready to jump head-on into casting. We choose an economic and easy-to-use plastic resin. Just like when we created the mold, we begin by mixing the resin components together. Then we pour the resin into the mold, making sure to keep the mold shut tight to prevent leaking. After a curing time of 10 minutes, our cast is complete. We now have a completed cast of Philip's head, and we can easily manufacture more.
It's a boy!
In this process, we use contemporary production and modeling techniques to demonstrate the basics of molding and casting. The process was fairly simple, but our final product was highly detailed. Looking good, Philip. This manufacturing demonstration shows how similar techniques may be used in the future for other purposes, like in biomedicine or art.